Understand how cosine is this graph from here to here? Well, then, okay, I'm talking to a student. I forgot I had to tape this, so I didn't do our class extrapolation. Maybe after this, as the student is asking this question, hopefully I can answer it as well. But we're graphing secant, cosecant. Silence! I can't talk over you. Okay. See, that student did that. That was that student's fault. Okay. We're graphing cosecant. So try to get your question, but cosecant's related to sine. So when I plug these values in, those are the four critical values for graphing a sine curve. All right? But then what's cosecant? It is the flip of sine. So all I have to do is flip these y values, and then those are the y values for cosecant. By the way, input, anyone? Input, output. And now I know that's what the output is because I just looked at sine's outputs and I flipped them. But the idea of what's the flip of 0, it's undefined, that turns into an asymptote. So wherever there are zeros for sine, those are asymptotes for cosecant. And then what is the flip of 1? 1. So these are shared values always between sine and cosecant's graph. And then what's the flip of small? Everyone say it. What's the flip of small? Large. That's why I did pi over 6 comma half. The flip of a half is 2. So that's why cosecant's graph behaves like this. And then the ends behave towards the asymptotes. So really all you have to do is accomplish graphing sine and then shared and flip this bowl part and flip it going up like this. Because that's really what's happening with the y's. Did it? Okay. And then this bowl gets flipped upside down. Okay, because the flip of very small negative is very large negative. I know that's a bad way of saying that, but the flip of 1 negative is still negative 1. All right, and then the same thing happens with secant. You graph the classic cosine graph with the critical values, then you flip the y's. And then we all know that sine and cosine are really the same graph. Like you could see a sine right here, right? Don't you see a sine? They're just shifted. So that's why cosecant and secant are very much the same. They're just shifted a little bit as far as the graph is concerned. So it'll be real easy. And it should be, and this should be review for tomorrow, except for that additional step. Now, don't write this down. That is true mathematically. It's confusing. But do write this. We did talk about this. For both graphs, the range is negative infinity to negative 1 bracket, then union that with 1 to infinity. And you can see it in the picture. That's for both secant and cosecant. So I can write that for both graphs, like somewhere in the middle. And then I guess I should talk about domain for both of them. They are different. And you're probably not going to like this, but I'm going to go over it real fast and then solidify it in more different questions. When you say domain, we're going to have to go back to an Algebra 2 way of notifying this. What's Algebra 2? They don't know what that is in Lockport. 99% of the rest of the country does. Hey, what can't x equal? Okay, remember undefined values. So can x equal 0, or does that give you an undefined output? Right? Can x equal pi? Yes or no? No. That's what asymptotes mean. Remember that from rational functions. Okay, so here's what you say for the domain. X cannot equal, and a not equal to sign means it can equal everything else but this. I didn't understand that when I was a kid, when I was a little punk in high school, tormenting teachers. And then pick one. Well, 0 is a nice one. X cannot equal 0. You'll see how this is useless after I do what I do here. And then how far are each one of these asymptotes away from each other? Half. Anyone? Half of the period. And you were right the first time when you said pi. So remember I did that on the last time I was here Monday when I said this is how you answer all, like all things that happen. And then what's n? N is any integer. I have to do that in this because a lot of people don't remember one thing from Monday. Okay, now this is different. Whoa, 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 whoa. This one's different. The only difference with this one is the domain is x such that, that's what this means. X cannot equal, where's the first naughty value? Pi over 2. What's not different? How far away are those asymptotes? Half the period, pi n. And that's how you write all answers, all asymptotes, because these asymptotes go on forever. Okay, so first hour I didn't show that with the original parent graph, but I did take one of our examples and talk about that. I'm not going to talk about domain and range on every example. I'll pick one, all right? And then it's not what you have to worry about tomorrow anyway. You might want to write one more thing. This is just giving the book props. Of course, you notice those two graphs never cross the x-axis. So the parents don't have x-intercepts, but watch yourself. The graphs can be shifted up or down, and therefore, if it is shifted up or down, there could be x-intercepts on new graphs. But the periods pi are 2 pi, because for cosecant, this is different than this. But then after that, we get u, 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 and it goes on forever like that. I'm putting them too far away, but an upside down u and a right side up u represents the full period. Then after that, the u's repeat themselves. So the period is 2 pi. You don't say it has an amplitude. This is something where I could be a jerk teacher, and I hope on the test we don't ask, what's the amplitude of a cosecant? Maybe I do. Maybe we are jerks. Because the idea of amplitude is there's boundedness to the graph. It has a high and a low point like sine and cosine. These, they go off forever, up and down, so there is no amplitude. There is no limit on how high or how low something can go. How low can you go, huh? All right. But you do say what is the a value just so you can graph it right. But there is no And then don't write this next part because I have it synthesized in a better way. That's just for secant. For both of them. Remember, sine is odd. Why? What's that sound for? Remember? What's that the sound for? Symmetry. They finally got it. Okay, and then this is symmetry with respect to the origin. And then the same thing would happen with secant. Because I have a bowl here and I have a bowl here. Across the origin. That's what we have there. Uh-oh. We're going to get some low battery capping in here. And then cosine. That's symmetric with respect to the y-axis. And the same thing would happen, I don't feel like drawing it, with secant. So secant, just like cosine is even, sine and cosecant are odd. I'm going to take a break for a second. I shouldn't have. All right. Yeah, they got to be tough. Yeah. I think we're growing too much weakness in this world, right? You need toughness, man. The world is. Can you imagine if we didn't have all our conveniences right now? We had to go live out in the forest again. Oh my gosh, people just lay in a ditch and cry. Oh, that's what we're animals, man. We should be strong, you know. Okay. Anyway, good talk. Okay, so this one's easy. By the way, I shouldn't have wrote this, but those that don't know that secant is related to cosine, you're severely anyone? At this point, it's over, man. What are we doing? Okay, but anyway, so this is not one where you have to do work off to the side. So we're going right to the graph. Meaning there is no up-down shift and no right-left phase shift. We're good. So now this is a review of something that should be simplistic tomorrow that everyone should get right. If I don't shift cosine right, left, up, or down, it's really easy graph to graph. And, okay, sorry. What's the amplitude? Wrong! There is no amplitude, remember? Okay. Secant and cosecant, there is no amplitude, but we do need to mark 2 on the x-axis. I'm sorry, the y-axis. And -2. Okay. What's the period? There is a period. Don't get tricked on this. What's the period? This one's easy. You don't even have to worry about fractions. You put 4 pi here and negative 4 pi. Looks like about the same distance. We're going to do 2 periods. What's half of 4 pi? 2 pi. What's half of 2 pi? Pi. No fractions. 1 pi. 2 pi. Anyone? 3 pi. And try to keep these equally distanced, then your graph won't be distorted. And it is harder to graph when you have a distorted x and y axis. It's pretty good. I feel like I have some imperfections in there, but I'll deal with it. Okay, so we graph cosine. Let's graph cosine in red. But you don't graph it as a solid line. This is not the graph. This is an aid to help me graph. If this was cosine, what do we have? 0, comma, what is it? 0, 2, or negative 2? Cosine kid starts high, pi, comma, goes down there, then the 2 pi, comma. I don't know what I'm trying to say. And then back to 0. You got it. Once you get those, how could you miss the rest? And then 0, and then low, and then 0, and then high. And then you're going to graph it as a dotted line because this is not the graph, but this is an aid for the graph. And I don't know what these people were doing that weren't marking the x-axis values. Good luck tomorrow. Because if you have some unmarked x values, you're gone on the quiz. This is the whole point, all right, of marking those. Oh, my goodness, how some people do their homework with not using what I'm doing in the notes at all. Okay, now, what did I say the reciprocal of 0 is? What's the reciprocal of 0? Undies. This is where the asymptotes go for secant per our extrapolation on this basic. I'll get there in a minute. Anyone getting dizzy? Oh yeah. Okay, there it is. Here on the extrapolation. Oh, did I go over that with the video? All right, here's the parent secant graph. You take the reciprocal of cosine values because secant is 1 over cosine. So whatever cosine is, you flip it. And the flip of 0 over 1 is 1 over 0. I don't know if I said this on the video officially. All right? And 1 over 0 is undefined. And then we talked about the behaviors of when I flip this, it's way up here. That's why the secant graph has those points. When I flip this, this is right here. When I flip this, this is right here. I did that with pi over 6 value, one of them. Okay? Yeah, whatever, you know. All right, so we should understand those asymptotes pretty well. So this is why I graph cosine, and then I flip the y values. That should be good enough for our video. All right, so the zeros of cosine are the asymptotes of the reciprocal brother or sister called secant of cosine. All right, now, I am going to over-explain this because it's Samuelus. He always over-explains. Is this still 0, or is this still 2, or is it the flip of 2, which is a half down here? I get people do that all the time with the secant graph. And it's 2. Here's why. I plug in 0 for x. What's 0 times a half, everybody? 0. What's the secant of 0? I don't know. It's 1. And then what's 1 times 2 still? 2. This is a shared value. Shared. 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 And then to flip this, these go up here. But I don't want that as a solid line there. Flipping those y values gives us this, and this, and this, and this, and this. And this solid thing that I'm drawing here, this is the secant graph. Okay, I told you secant and cosecant are almost the exact same graph. This is considered one secant. This is considered the second secant. So I do have 2 periods worth. Okay, just so you know. And that is the answer. That is the graph of secant. Hold on, I gotta find my pause. Oh, great. All right. Oh, all right. Okay, here we go. Here we go. Domain and range. Domain and range. All right. What's the range? This one's easy. What's way down here? What's way down here? What kind of infinity? And then all the way up to here. Oh, so it's negative infinity to what? Again, I'm traveling along the y-axis. What y values are covered? Never understood how students have a problem with domain and range. Domain sometimes tough. Range never. Okay, and then, oh, there's nothing in here. And then it starts here all the way up. So it's 2 to infinity. Range, what is this thing? Get this out of here. Okay, 2, I know I put it there, but... All right, now domain. Okay. Well, all we have to do is say this. Okay. All right, this is called, what is this called? Set builder notation? No, I don't remember what this is called. It just means x such that x does not. I don't remember because we don't use this anymore. But for when you have to say the domain is not equal to, which means it equals everything else but, you got to go back to this notation. You can't use interval notation very well. What's one of the values it can't equal? What's one of the asymptotes? Pi. Okay, how far are they away from each other? That should be simple in this question. And it is actually half of the period. That's something to remember. Whatever the period is, these are always half the period away from each other. Okay? Now, guess what? You know what else they ask you? What's the equation of all of the asymptotes? You remember 2 days ago on Monday, the last time I was here, I showed you how to write all, and this is how you write all, where n is an element of integers. These are integers that I plug in 0, 1, 2, -1, -2. I end up getting all those all those undefined values. Now, what's an equation of a vertical line? It's x equals a number. That's the equation of a vertical line. So what's the equation of all the asymptotes? It's right here. It's exactly what the domain can't equal, right? Isn't that where the asymptotes are located? So if you can get the domain, you can get the equation of all the asymptotes because they are one and the same. They're intertwined. They're interlinked. All right? So x equals a number is the equation of a vertical line. So x equals, pick one, and find out how far all the rest of them are away from each other. So there is no coincidence that these two have the exact same, expression, I guess I could say. But to say this is the domain, this is what x can't equal, because that's where the asymptotes are located. One and the same. Aight? And then that's what I have down there, just rewritten. Okay? All right, and then who cares about that? That's the book's representation of cosecant. Let's move on. Oh, no. Now we have a what? Phase shift. So we're just going to do one cycle. On the test, I think when we had phase shift, the quiz tomorrow, I think with phase shifters, I might only have one cycle that you have to draw. Because it's a little tough. I'd like you to just see where it's located. I may be wrong in that. Don't call me a liar. Okay. All right. So cosecant, you graph sine. How do we graph sine? With the phase shift, we put our critical values off to the side. By the way, A is 3/2. That's how we're going to mark the axis. And I guess I could draw the coordinate plane real quick and just put those 3/2 values down. Shh. Oh, I was only going to do one period. But actually, this doesn't, I think, end up being too bad. We have a question. So he asked, didn't you say there's no amplitude? You're not supposed to say there's an amplitude. If you're literally asked, this is one of those semantic, annoying math details that math teachers like to mark students wrong with. The term amplitude implies that there's a high and a low. All right? There is no high and low with secant and cosecant. So you call it an A value just to locate it on the graph, but the semantic is you don't say there's an amplitude. Yeah. Hey, what's the period, by the way? I don't see any special numbers, so what is it? It's 2 pi. But what we have to do is, if you want to do it the Samuelus way, the organized and neat way when we have a phase shift, is you do your math off to the side, and then you put your critical values down. And then know that's where, in this case, sine starts, and then we're going to turn it into a cosecant by the flipping thing. All right, so if it's minus pi over 2, the phase shift is pi over 2 which way? if you had to denote this. Right. How do you move pi over 2 right? What do you do? Add or subtract? I heard the add. And you know what? We've done this a few times. I'm just going to be lazy and do this. First one's easy. Next one, maybe not so much. Oh, this is going to be easy to do 2 periods. But I'll tell you why in a minute. What's pi over 2 plus pi over 2? Pi over 4? Get out! What's pi over 2 plus pi over 2? I didn't just kick someone out, but if you think pi over 2 plus pi over 2 is pi over 4, Lexi Samuelis would look at you and just shake her head. It's 2 pi over 2, which is what? Pi. And then this is 2 pi. I think we should figure this out. What's 2 pi over 2 plus pi over 2? 3 pi over 2. We should figure out what the next one is. 4 pi over 2. And then what's the last one? 5 pi over 2. This is why this is going to be easy to do 2 periods. So forget you. I'm doing 2 cycles. Pi over 2, pi. And notice my distance from here to here, I made the same as from here to here because I know something. All right, but let's get that first cycle done. 3 pi over 2. This is nice. 4 pi over 2. 5 pi over 2. And you feel free to add them if you don't figure out that this pattern, how I knew that was going up by pi over 2. Of course, the distance from here to here is pi over 2. The distance from here to here is still pi over 2. Quarter of the period. All right, how do you graph sine? Where do you start? High point or low point or middle point? 0, the middle point. And then pi comma. In this case, 3 halves. 3 pi over 2, 0. Then down to the bottom, then here. Okay, let's finish this graph for cosecant. What happens to the zeros, everybody? They turn into what for cosecant? Asymptote, one student said. No one like in the 90s, the students would all say, asymptote, Mr. Samuelis. Now it's nothing. Nothing. Kids don't talk. They stare at their screens. The computer controls their lives. Oh, let's see. Hiding behind your books. Hey, remember what I said about this? Shared. You don't flip 3 halves. The order of operations says when I plug in pi minus pi over 2, then I cosecant it. I get 1. Then 1 times 3 halves is still 3 halves. Input, say it. And then I didn't even graph this because I know what I'm doing. But the flip of that is this. So that's why that's that graph. And you draw this as a dotted line. The flip of that is this. And then it behaves towards the asymptote. The flip of these, it's supposed to be red. The flip of this, oh, that looked too pointy. You should never be able to kill someone with your sine curve. It should be nice and curved and look like a pillow, not a point. Okay, got it? All right, now, how come 2 periods would be very easy? Because all I have to do is go how far this way to get the next critical point. Pi over 2, the quarter of the period value. So this is a critical point. Then what's the next one? What value would that be? Negative pi over 2. Student in the back should do well tomorrow. He's been answering a lot of my questions. Negative 3, he's getting credit in 4th hour. All right, and then sine would go like this. Down to here, low point. Back up to here, 0. Back up to here, high point. And then back down to here, low point. Then I'll just pick a different color for this one. Asymptote. This is period number 2. This is cycle number 2 if we did 2 cycles. This one is very doable. Some of them not, when the phase shift doesn't match very well with the period or the quarter period value. Yeah, couldn't find. I'll verbalize the range. Negative infinity to negative 3 halves, right? 3 halves to infinity, right? And then what's the equation of the asymptotes? It's actually really easy. It's x equals. This is the same thing. What's the domain? Just put a non equals there. So the asymptotes are all x equals. Pick one. Hey, that's one of them, right? This one. And then how far away are these? How far away are those? It's pi. The period's still 2 pi. So it's half the period away because, this is a full graph from here to here. Well, this is half of the graph. Therefore, it's half of the period distance. Okay, so that's the equation of all the asymptotes. You don't have to worry about that tomorrow, but we do have that on the chapter test next week. One more fast one, and then one more very complicated one. Okay. Oh, no. All right, but I'm going to set this up right now. What does that mean? What is that -2 or -2 plus? What does that mean? It's a vertical translation. Which way? Down. I'll go back to my normal colors. I'm going to do this right now, and you should remember this from my glorious teaching of shifting up and down. The amplitude is not. It's not an amplitude. Let's say A equals 3. So this would have went from 3 to -3. But when we go down to, what does 3 become? 3 becomes what? If this was 3, it's 1. So I'm going to mark 1 as my critical value. And then here's -3. But where does -3 get moved down to? -5 are my critical values. And then what should I make a dotted line on? Too late, I'm already doing it. Where should I put a dotted line on? What do I call -2 through the y-axis there? Those are where the new zeros are located for cosine. Because I'm going to graph cosine. This is where the new zeros will get moved. What is still the reciprocal of 0? What is still the reciprocal of 0? Undefined. So anytime we hit this dotted line, that's where the asymptotes are for secant. That's what we need to know. So that's all we have to do is be able to treat this as a translated graph down, and then the rest is going to be easy. What's the period? I don't want to get, I can put it here, the graph. The period is pi over 2. So this is why this one we don't have to do work off to the side. There is no phase shift. We're just going to put pi over 2 right here. It's probably going to be in the way of my question. What's half of pi over 2? Pi over 4. What's half of pi over 4? I've gone over that in other videos. I'm done. 1 pi over 8. 2 pi over 8. 3 pi over 8. Then you flash them to the other side and make them negative. So doing 2 periods on this is not a big deal. Oops, I don't like that distance. It is better to have good spatial distance here. You can't say I'm going too fast. I'm trying to be real careful. You can't say I'm going too fast. You'll just be a liar. All right. How does cosine graph? Oh, I didn't do a mistake. I did a mistake other but not on this. Where's cosine? Is it 1, -2, or -5? Which one is it? Starts with the high point, then goes to 0, air quotes, air quotes. The new 0 is down 2, though. And then -5. Were you listening when I did the shifts? You guys got the deer and headlights look over there. Okay. Not flipped. Nope, nope, nope. It's moved down. It's because they write the plus minus, they write it in front. This is equal to just writing it like this. Secant 3, secant 4x minus 2. And you're used to seeing it to the right. For trig, they write it on the left side, at least in this book. And then, sorry, I should have done this. This, what time is it? This? Oh, dear. Always with you guys. It's my fault. It's not yours. All right. And then for secant itself, I'll graph that in red. These are where the asymptotes, these are still the zeros that still flip to be undefined. That's why we put that dotted line there. We make sure that's where our new zeros are located. It's really very simple to do. So, all right, I'm going to stop stop writing it. Remember, for tomorrow's quiz, you'd write this as a solid, and that's it, right? Right? That's why this is review, right? Okay, that's tomorrow's quiz. That's what you're going to have to do. Got it? Okay, but now just today, it's the added step of how does that turn into secant? Well, those are where the asymptotes are, and then we flip. Shared flip. Shared flip. So really, the real math is graphing the cosine and finding those critical values. Okay? All right. Then last but not least, you should be done with that. And I'm just going to go over this one, and as you walk out the door, that's fine. But this is for the people that are absent, and no excuses. Your quiz is Thursday. I want to hear, well, I was watching heart surgery. I don't care. All right? All right, remember this 1 minus. This is like saying plus 1. Okay, so what does that 1 mean? Vertical shift up. Oh, no. What do we have also? Phase shift. And I forgot to do this first hour. I forgot to make our graph upside down because I got all caught up in all the other things that I was doing. And somebody caught me at the end. So thanks for that. That was actually good. No one else said a word, though, in first hour. Just like, sure, go ahead, whatever. Hey, you know what the problem is? The problem is that negative a half, this is like negative a half to a positive half, right? Right? But it gets moved up 1. So where does this end up becoming? Where does positive a half end up becoming? 1 1/2 is a critical value. Where does negative 1/2 get moved to? Up 1 1/2. And then where should I put my dotted line? Through 1. So if I were going to graph this as cosecant's related to sine, this is going to be a real cute sine curve in here. Aw. Okay. Really not very tall because of the amplitude. Not an amplitude, but I can say amplitude for sine. But I can't say amplitude for cosecant. All right. And then, oh no, I got to do my work off to the side. By the way, there's a 1 in here, so it's still 0 to 2 pi. Half of 2 pi is pi. Half of pi is pi over 2. 1 pi over 2 pi. You've seen this one a million times. Hey, what's the phase shift? 3 pi over 4 to the what? So I have to add it. And then basically I'm going to have to get these as denominators of 2. And watch how I write this. 3 pi over 4, I'm going to write this like this far. And then the next one's about this far. This is bigger than this. Because I know 3 pi over 4 is bigger than pi over 2. The distance from every quarter point on the period thing. So I'm going to write 3 pi over 4 as our first point. And then I might run over my graph. That's fine. What's 2 pi over 4 plus 3 pi over 4? And then what do you think the next one is? 7 pi over 4. From that, you connect. You connect a pattern immediately. What's the next one after that? What's the next one after that? And we're going to discount double check that. Is this last one when this is 4 pi over 4? Or no, that's not 4. That's 8 pi over 4. Plus 3 pi over 4 is 11 pi over 4. Dang tootin'. I got all my critical values. Now for sine, it's 0. Flipped, sorry first hour, low point, 0. High point, 0. And then if this was 1, 1, 1, period, we'd take these and flip them. So this would be an asymptote. It's not going to really look much different with this squished sine curve compared to what the cosecant curve looks like. But we're all good and should understand that the flip of 0, air quotes, these are where the zeros are located, is still undefined, which means that. And then, pew! Oh, there's an x-intercept. I told you there would be x-intercepts if we shift up or down. Could be. I shouldn't say will be. All right. And then I did do this with first hour. Well, you know what? Another cycle would actually not be that hard. All right, adding 3 pi over 4 gave me these critical values. This is still a distance of pi over 2 from each one to each one. And these are all over 4s. So the next one should be, let me try to do the same distance there, pi over 4. And then this gets skipped as a critical value. Like I told you, sometimes the hardest thing to know. Negative pi over 4. Negative 3 pi over 4. Do I like that distance? I guess so. And then I think negative 5 pi over 4 finishes it off. And then for sine, okay, upside down, this would be a new high point. This would be skipping. So I'm a little distorted. It's really hard. Low point. This is the sine curve continued on the other side for a second period's worth. Asymptote. Asymptote. Flip. Flip. You can stop now if you want, if you've had enough, but I'm going to go ahead and do the range. Range is negative infinity all the way up to this value, which is a half. Wrong. It's a parenthesis. Union that with bracket 1.5 to infinity. And then the domain, hammer this point down yet again, is x such that x cannot equal, pick one, 3 pi over 4, plus, how far away are all of these? Half of the period. And then, like I said before, what's the equation of all the asymptotes? Vertical lines are x equals a number, and it's those numbers. The numbers that create the problem with the domain in the first place. All too easy.